In number 40, we're asked to find solutions to the equation. You can find solutions by graphing or completing the square, or factoring, or solving by the quadratic formula. I'm going to solve number 40 with the quadratic formula because the quadratic formula works every time. In order to do that, I have to have it in standard form, so I'm going to subtract 7x from both sides so that I have the equals 0 on this side. Then I'm going to remember my song. X equals negative b, which is 7 plus or minus square root, that didn't turn out, square root of b squared, minus 4ac all over 2a. Alright, so that was a slow version. You can Google that song if you'd like to hear a more on-pitch version. But now I'm just going to simplify. I've got 7 plus or minus the square root, negative 7 squared is 49, minus 4 times 3 times 3. 4 times 3 times 3 is 36. So I have 49 minus 36 divided by 6. Now 49 minus 36 is 13. And as we know, we can't simplify the square to 13 unless we use our calculator because it's not a perfect square. So the answer key leaves the solutions like this. We're not going to have a rational solution, so if we did this on our calculator, we wouldn't get this version of the answer. We'd only get decimal version of the answer. But you can always put the answers in this format if that's what you end up getting in your calculator, to see if they match the decimal form that you get when you graphed. Pause the video if you need to. I'm going to erase this to do number 41. 41 asks, is x minus 4 a factor of the polynomial x cubed minus 7x minus 6? To determine that, I'm going to use synthetic division. Because I'm trying to see if this is a factor, I'm going to put 4 in the box. And I get 4 from just solving the equation x minus 4 equals 0. I'm also going to write the coefficients of the polynomial in order. Remember, we only want to drop 1 degree at a time, so we've got to jump in between these two because x cubed should go to x squared next. So I'm going to hold that place with a 0. So I'm going to put a 1 for the x cubed, a 0 for the x squared, negative 7 for the x, and negative 6 for the constant term. Bring down your first coefficient, multiply, and add. So 1 times 4 is 4. We're going to write it and add. We're going to multiply 4 times 4, that's 16. Write it down and add. 9 times 4 is 36. We're going to write that down and add. So as we know, this last value here is the remainder. And if this number is not a 0, then no, this was not a factor of the original polynomial, x cubed minus 7x minus 6. So your answer, number 41, has to be no. I think the answer key says yes, but that's incorrect, and we need to fix that. Pause the video. I'm going to erase this to do number 42. In number 42, we're supposed to solve a log equation. To solve a log equation where an x is trapped inside of a log, we have to change it into an exponential equation. Remember, to do that, I'm going to have to know the base of this log. And the base of it, since there's not one written, is going to be a 10. Then we're going to take the 10 as the base, raise it to the exponent of 3, and set it equal to 4x plus 10. So 10 cubed equals 4x plus 10. 10 cubed, as we know, is 1,000. So 1,000 equals 4x plus 10. Subtract 10 from both sides, and I get 990. Divide both sides by 4. It's not going to go in evenly, So you can simplify it as a fraction or as a decimal. As a fraction, this would be 495 over 2. As a decimal, this will be 242.5. I think the answer key leaves it as a fraction, though. Sorry, that was bad mental math. That would be 247.5 as a decimal. So we'll leave it as a fraction. Go ahead and write that one down. I'm going to erase it to do number 43. In number 43, we're asked to simplify, and it's hard to tell, but this is a divide sign in the middle. When we divide rational equations, we're going to have to factor first and then keep the first fraction, change this to a multiplication, and flip this over. So I'm going to try factoring first. I can't factor x plus 2, so I'll leave that alone. Can't factor x minus 1, so I'll leave that alone. I'm going to change divide to multiply. And I'm going to factor and flip. I can't factor x plus 4, so I'm just going to move that to the bottom. But I can factor x squared plus 4x minus 5. When I do that, I'm looking for two things that multiply to give me negative 5, but also add to give me 4. And those are going to be x plus 5 and x minus 1. Now, because this is all multiplication, if I see anything in the numerator that matches something in the denominator, I can divide those to get a 1. So x minus 1 and x minus 1 will divide to give me a 1. And now I'm left with x plus 2 and x plus 5 in the numerator and an x plus 4 in the denominator. Now, one thing that you'll see on your answer sheet that's not implied here, because it doesn't actually mention it, says to state the restrictions. And restrictions, remember, come from the denominator, whether it was originally in the denominator or is now in the denominator, even before it was canceled out. So we set these restrictions equal to 0 to see what x cannot equal, because we can't divide by 0. So x minus 1 can't equal 0. That means that x cannot equal positive 1. We also see that this was in the denominator. When we factored it, we got this. Neither of those factors can equal 0 either. So x plus 5 can't equal 0, which means x can't equal negative 5. We've already taken care of the negative 1 with the first thing we did. The only other thing that was ever in the denominator was this x plus 4. That can't equal 0 either. So that means that x can't equal negative 4. So those are our three restrictions on the variable. Now I'm going to erase that and do number 44. Number 44, we're asked to find the inverse. Our steps for finding the inverse are, number 1, switch your x and your y. So x equals 7y squared minus 3. Next step is to get y alone. So I'm going to add 3 and divide by 7. And finally, I'm going to take the square root of both sides. Taking the square root of this side leaves me with just a y. Taking the square root of this side, I have to do plus and minus square root of x plus 3 over 7. So that's our inverse for number 44 for you to write down. Number 45, you could do in your calculator if you wanted to. The main thing for this one is to remember that the sine function normally goes through the origin. It does something like this. Sorry. It starts here and it goes up, down, like that. But when you add a 4 to it, like you see in number 45, it's going to take this whole thing and shift it up 4 units. So this is -1, this is +1. If I'm going up 4 units, I'm going to be off this graph and even off this piece of paper that I'm looking at here. Well, I'm going to see what I can do anyways. 1, 2, 3, 4. So my new sine function is going to start right here and go up to down, up, down, like that. 0 would be right here, and 2 pi would be right here. So it's actually going to stop if we're just going from 0 to 2 pi, right back on the line y equals 4. That's what we call our midline. That's number 45. 46 asks us to find the zeros of x times x minus 3 times x minus 2. To find zeros, we can just set the equation equal to 0 and then set each factor equal to 0. And you guys can probably solve these in your head, so I'm wasting your time right now. But we end up getting x equals 0, x equals +3, and x equals +2. To graph the equation, we can put it in our calculator and take a look at the picture. We're going to end up with something like this, where this value right here is 2, and this one is 3, and this one is 0. And of course, we'd have arrows on the ends, to be precise. That's number 46. Number 47 asks you to find the amplitude of it. On your review sheet, you couldn't see that very well. But for amplitude, remember, we want to know how high above and how low below we are the midline. And it's a little confusing where the midline is right now, but it's not right here on the x-axis, because we go up 3 here and down 4 here. Well, the amplitude should be the same above and below the midline. So we're going to have to move the midline down a little bit. We move it down just a very, very little bit to 0.5. Now we have to go up 3.5 from the midline and down 3.5, because the lowest we ever get to is 4, the highest we ever get to is 3. So our midline is going to be halfway in between those two numbers at y equals 0.5. So our amplitude is 3.5, because we go 3.5 above and 3.5 below the midline.